Okay, so as you saw in that video, a mole is equal to 6.022 times 10 to the 23 atoms or molecules or, formula units. Atoms are for elements. Molecules can be for elements or covalent compounds. And then formula units are what we're going to use for ionic compounds. Alright, so let's practice. Convert 3.5 moles of helium to the number of helium atoms. So I've kind of given you a conversion factor. So because we know that 1 mole of anything, in this case we're going to use helium atoms, is equal to Avogadro's number, 6.022 times 10 to the 23 of those helium atoms. We can use it as a conversion factor. So go ahead and pause, do the math out, and see what you get. So I should have 3.5 moles of helium, and then I should have Avogadro's number of atoms of helium over 1 mole of helium. Alright, and careful how you put it in your calculator, but you should get 2.1 times 10 to the 24 atoms of helium. Sig figs are going to be 2 here because of the 3.5 moles, the sig figs I have here. Alright, try it again. Okay, so to do this one, I have 1.1 times 10 to the 22 silver, which is Ag atoms. And I want moles, so 1 mole of silver atoms is going to equal 6.022 times 10 to the 23 silver atoms. And then this time I'm going to be dividing, so careful when you're putting this in your calculator, because if you do put it in the wrong way, you're going to get an answer that's a lot different. So you should be getting 0.018 mole of silver. If you don't get that, let me look and see how you're putting that in your calculator. So different substances have different masses, right? If we have a dozen large nails, it's going to weigh differently than if we have a dozen small nails. So every substance on the periodic table has a different molar mass, or mass per mole, or mass per that many atoms. So a mole of sulfur, if you look on the periodic table, you'll see that the AMU, what we were once calling the AMU of sulfur, we can see that that is actually the gram per mole. So sulfur has a mass of 32.06 grams per mole, and carbon has a mass of 12.01 grams per mole. And that's really helpful for us in the lab because I can go and get a mole of a substance and weigh out how much that is. And then I know how many atoms of sulfur are in my sample using Avogadro's number, which is pretty cool. So let's try it. Calculate the number of moles of carbon in a 0.58 gram diamond, which is just pure carbon. Okay, so I have 0.58 grams of carbon. I know the molar mass of carbon is 12.01 grams per mole. Because it's grams per mole, I can write it as a conversion factor. Okay, that's how many grams equals 1 mole, so I can put it as a fraction. I need the grams to go on the bottom, and I want moles to go on top here. So I have 0.58 divided by 12.01, and I get 0.048 with sig figs. That's how many moles of carbon in that sample of diamond. Alright, we're going to take that one step further and we're going to do the number of atoms of carbon. So go ahead and pause and work this out. Okay, so we have the number of moles of carbon. I'm going to start from the beginning though to show you how you'd piece it together. This many grams of carbon. The next thing I need to do is find molar mass. In 1 mole. Okay, so now I have moles of carbon, and if I have moles of carbon, then I can use Avogadro's number to figure out how many atoms of carbon are going to be in that sample, because Avogadro's number tells me atoms per mole. So I should get 2.9 times 10 to the 22 atoms of carbon, and that's my answer. Okay, try again. Alright, so I should have 16.2 grams of aluminum. I'm going to use the molar mass of aluminum here. That is 26.98 grams of aluminum is equal to 1 mole of aluminum. Cancel my grams out. Then, now that I have moles, if I want to go all the way to atoms, I'll just use Avogadro's number. In 1 mole, I'll have Avogadro's number of atoms. Cancel my moles out. Now I have atoms of aluminum. And I should get 3.62 times 10 to the 23 when I account for sig figs. Another practice. Go for it. If I have 1.75 moles of water, how many grams is that? So now I have to use a formula mass. So how do I get this 18.02? Well, if I have water, I have 2 hydrogens, and I have 1 oxygen. So that gives me 18.02 grams per mole. So I can write 18.02 grams equals 1 mole, and I can put it as a conversion factor whichever way I like. So in 1 mole of water, I have 18.02 grams. So that's 1.75 times 18.02, and that's going to give me 31.5 grams of water in this many moles of water. Alright, try this one. So, I want mass, so this is a little more complicated, so we're going to put question mark grams are equal to 4.78 times 10 to the 24 molecules. You can abbreviate molecules as cules if you want, but don't abbreviate molecules as moles because that's different. So if I want grams and I have molecules, anytime I have a tiny amount of particles, I know I need to use Avogadro's number. Now, Avogadro's number, as you can see here, gets me to moles, not to grams directly. So I will need to use 2 conversion factors here to get to that answer. So go ahead and try that if you got stuck on it the first time. We're going to start with our 4.78 times 10 to the 24 cules, molecules. We use Avogadro's number on the bottom here to cancel out our molecules. That's equal to 1 mole. If I want grams, then I'll use the molar mass. So 1 mole is 46.01 grams. Where do I get that number from, this 46.01? Well, I have 1 nitrogen, and I have 2 oxygens. And I'm going to add those up. It's going to get 46.01. So 4601 divided by Avogadro's number times 4.78 times 24. I just went backwards there, that's fine. What's the mass in grams? 365, 3 sig figs grams of NO2. And if you want to practice naming, what is that called? It's called nitrogen dioxide. Okay, so we can also use chemical formulas as conversion factors. So conversion factors, as you know, get us from one unit to the other. So a chemical formula we can set up as a conversion factor. So for example, if 1 clover has 3 leaves, then I can say 3 leaves is equal to 1 clover. So if I have 14 clovers, how many leaves would that be? Well, 1 clover is equal to 3 leaves. I can use that as a conversion factor to figure out how many leaves. So we can kind of count how many atoms are in a compound and use it as a conversion factor to one of those compounds. So the same thing goes for 8 legs on 1 spider, 4 legs in a chair, and then for every 1 water molecule, I have 2 hydrogen atoms. So I can say 2 hydrogen atoms is equal to 1 water molecule, and I can put that on top of each other as a conversion factor if I need to, right? 1 water molecule, or I can flip that and use it however I want. So let's practice that. Find the number of moles of oxygen in a 1.7 mole of calcium carbonate. Okay, so I'm going to start with my 1.7 mole of calcium carbonate. How many oxygens are there in calcium carbonate? Well, there are 3, so therefore there are 3 moles of oxygen for every, there are 3 moles of oxygen per every 1 mole of calcium carbonate. It doesn't matter if I use the unit atoms or moles. If I'm using a mole, I would just use the same ratio. So this is what we call a mole to mole ratio. It's the ratio just between moles of things. Because moles are a counting number, we can say moles are equal to these formula units, and moles are also equal to the atoms, so we can kind of not have to worry about using the unit atom or formula units. We can just use moles as our unit for this 1 to 3 ratio we see. So I'm going to take 1.7 and multiply that by 3, and I'm going to get 5.1, and the unit is going to be mole of oxygen. And make sure you tell me what substance you're talking about now, because we are talking about a bunch of different types of moles of things. Alright, one more practice. Find the mass of sodium in 15 grams of sodium chloride. Okay, so we're going to start with the 15 grams of sodium chloride, but they want only mass of sodium. So I have to take it through a mole ratio. Anytime you change substances, you're going to have to take it through a mole ratio. So how do I get to a mole ratio? Well, first I have to get to moles. How do I get to moles from grams? Molar mass. So I take the molar mass of sodium, and that's equal to 1 mole of sodium chloride. I'm sorry, this is sodium chloride. So cancel out grams of sodium chloride. Now I have moles of sodium here. The next step is going to be to go to moles of sodium from moles of sodium chloride. This is my mole to mole ratio. In every 1 mole of sodium chloride, I have 1 sodium, so that's just a 1-to-1 ratio. Now I have moles of sodium, and I want grams of sodium. I can use the molar mass of sodium alone to get that. Okay, so I'm going to just do the math really quick. 15 divided by 58.44 times 22.99, and I get 5.9 grams of sodium in 15 grams of sodium chloride. It's not a 50-50, right, because each element weighs a different amount. So here again, this is kind of that mole relationship. In every 1 mole of CeCl4, carbon tetrachloride, there are 4 moles of chlorine. And that should get you through what we need for this week, and then we'll finish up chapter 6 later. Thank you.